Have you ever watched a system, maybe a company or a project, that looks perfectly healthy from the outside, only to see it suddenly, catastrophically fail? It almost always feels like a total surprise. But what if it wasn't? What if the failure was actually built into the very structure that made it look so successful in the first place? Well, in this explainer, we're going to uncover the hidden forces that make complex systems appear stable right up until the moment they break. It all starts with a core belief of the modern world. You've heard it a million times. We apply it everywhere. To manage something, you have to measure it, right? It sounds completely logical. I mean, it's the very foundation of data-driven anything. But the moment we start to measure, things can get weird. Take a look at this data for 2 kidney stone treatments. Treatment A is clearly better for small stones, 93% success versus 87%. Okay, and it's also better for large stones, 73% versus 69%. So in every single category, treatment A is the winner. And yet, when you look at the overall success rate, the big number you'd use to manage the system, suddenly treatment B is better. So wait a second. Our core belief that measuring leads to better management just got turned on its head. So how on earth is this possible? How can the option that is superior in every individual case be the inferior choice when you zoom out? Now, what's so fascinating here is that this isn't a typo. It's not a mistake in the math. This paradox is a clue. It's pointing to some kind of hidden structure, a force that's operating beneath the surface, warping how we see things. To get a handle on this force, let's use a physical analogy. Picture a real landscape. This is the territory. It is infinitely complex, right? It's got jagged peaks, hidden valleys, unpredictable fault lines. This is reality in all its messy, detailed glory. Now, you can't operate on that level of complexity. It's just too much. So to make any sense of the territory, what do? We create a map, a summary. And this map has to be simple. It smooths out all those jagged edges, it ignores the fine details, all to give us a clean, understandable picture of the whole thing. And this leads us to the first crucial step in this full process. Let's call it the clean view. The system literally stops operating on the complex territory itself. Instead, it starts to navigate using this new, simplified map. From this moment on, decisions aren't based on messy reality anymore, but on this elegant, clean abstraction of it. And inside this new, simplified world, everyone gets a very clear, very rational goal. Improve the metric. That's it. Make the number on the map go up. Whatever that summary measurement is, overall success rate, quarterly profit, you name it, the one and only objective is to optimize it. And at first, hey, this works great, the metric improves. From the map's perspective, the system is getting more and more efficient, more successful. The numbers just keep climbing. The summary view shows a system that's undeniably getting healthier. Everybody's doing their job, and they're doing it right according to the rules of the system they're in. But this intense focus on the measurement, it introduces a hidden cost. A subtle drift starts to happen. People aren't trying to improve the complex reality anymore. They're trying to improve the simple number that represents it. And, those two things are not always the same. The actual quality, the thing we all really care about, it starts to erode in ways the metric just can't see. Now, let's be really clear here. This isn't about bad people or incompetence. This is all about the rational local choice. Every part of the system, every doctor choosing a treatment, every manager allocating a budget, is making a perfectly logical decision based on the information they have. They are just following the map they've been given. And this is where a really dangerous divergence begins. The official view, the story told by the big aggregate numbers, shows a system in perfect health, getting better all the time. But the ground truth, the unseen reality of the territory, is that hidden stresses and fragilities are quietly building up right under the surface. And this divergence isn't just some weird theoretical thing. It pops up in real-world systems all the time. For example, if you look at the data, wealthier states in the US tend to vote for one political party, but wealthier individuals within those exact same states tend to vote for the opposite party. The behavior of the group is the complete reverse of the behavior of its members. The summary tells one story, the details tell another. So, as the system gets more and more confident in its simple map, something irreversible happens. All that original, complex data, the detailed reports from the ground, it's now treated like noise. It contradicts the clean story being told by the summary, so it gets archived, ignored, and eventually just thrown away. At this point, the summary is no longer just a tool for understanding the territory. It has actually replaced the territory. The ability to see alternatives, to even question the model, is just gone. The system is now blind to the very reality it's supposed to be managing. This leads us to the divergence. That gap between the measurement and reality just keeps getting wider. But since the system has thrown out the tools to see the details, it's basically flying blind, totally unaware of the growing danger. And the numbers on the dashboard? They look better than ever. This isn't some random accident. The system actually locks itself into this simplified view through a series of logical escalating steps. First, the simple map is created. Second, you align all the incentives to improve the map's metrics. Third, you start committing real resources, real investments based on that map. And finally, that very commitment makes it impossible to ever go back and see reality again. Let's go back to our physical analogy to see how this gets real. A physical commitment is now made. A dam is designed and built. Its location is based on the average terrain shown on that simple map, a map that, for the sake of simplicity, smoothed out a critical geologic fault line. It just averaged it right out of existence. And this is just a brilliant illustration of that final stage of lock-in, where the map literally becomes the territory. The system isn't just conceptually blind anymore. It is now physically, structurally bound to its own flawed summary. The concrete has been poured. Escape is now impossible. The map didn't just replace the territory in theory, it has now reshaped it in reality. And so, the consequence, the one that was always there, hidden in the details of the territory, it finally emerges. The fault line gives way, the dam breaks. To an outside observer, it looks like a sudden, shocking failure from a system that seemed to be doing great. So here it is. We can finally put a name to the mechanism behind this whole process. It's called the aggregation problem. The very act of summarizing data, of creating that clean, simple map, inherently destroys information. And that loss of detail isn't just irreversible. As we saw, it can completely flip the trends we think we're observing. This one single structural force explains all the paradoxes we saw from the very beginning. It's why the better kidney stone treatment can look worse. It's why group voting patterns can contradict individual ones. It's why a rising efficiency metric can hide a total collapse in quality. When what is measured replaces what is important, the system is already on a path to failure. And this final realization, well, it reframes everything we've seen. From a structural point of view, the system wasn't broken, it wasn't being irrational, and it definitely wasn't poorly managed. In fact, you could argue it was managed with near-perfect efficiency, according to the rules it was given. The system didn't fail, it did exactly what it was designed to do. The collapse was the inevitable, predictable end result of a structure that was built to value a simple summary over a complex reality. It perfectly executed a plan that was, from the very start, built on a flawed map. And the question that leaves us with is, how many of our own systems are navigating by the exact same kinds of maps right now?